use to manipulate your data for your relation. Okay, another symbol that you can use is what we call as relational image. So relational image, the concept is the same as domain restriction. Okay, not range restriction, domain restriction. So if you want, okay, the shortcut for domain restriction, you can use relational image, assuming that you don't want to show the domain data. It's the same as domain restriction, but the result will be only range data. Okay, the result will be only range data. So relational image is actually the what do you call it? The crescent symbol. Okay, opening, closing crescent symbol. Okay, plus sabit symbol. Okay, so this is actually the symbol. The result will be the domain data only. The range data only. Okay, the result will be the range data only. Remember, relational image will produce the range data only. Domain restriction will produce both domain and range together. Okay? So when you want to use relational image, you're checking, okay, your what you want to search will be only the domain. You cannot search from the range data. Okay, directly, you cannot search the range data if you want to use relational image. Okay, the way to write for relational image is actually, even though you are looking at the domain data, okay, the way to write will be similar to range restriction writing. Means you are pointing to the right. Okay, you are looking to the right because the result will be range data. Okay, so the one that you are searching will be on the right side of your record. Okay, so this is relational image. So the symbol is this one. Okay, the symbol is this one. Okay, so same thing. If you are looking for the data which are not there, the empty result will be showing there. You can have something like this, 2 records, okay, and then like this. Or, okay, if you want, okay, it's similar, okay, if you write the domain restriction just now, or using relational image. So when you want to go for your, manipulate your data, if, okay, you have the domain data, you can choose either to go for domain restriction or relational image. Okay, according to what way you want to do that. Okay, either way to write, as long as you get the correct answer, is okay one. Okay, so it's either this domain restriction, but of course domain restriction you have to go with rand, but for relational image you don't have to go for rand at all, because automatically the result will be the range data only. That is relational image. Okay, inverse. Okay, inverse means swap the record between domain become range, range becomes domain. Okay, swap Okay, like terbalik lah. Domain become range, range becomes domain. Okay, that is inverse. Okay, that is inverse. So you are swapping, okay. So this one is example only, So if let's say you have cost here drink to Z, and then these are the sample of data. So if let's say you want to talk about buys here, Z to drink means the other way around. So if you want to show the relationship between between cost and buys here, okay, you can use something like this. Inverse. So the inverse is the tilde symbol. Okay, tilde symbol. So that is the inverse symbol. So when you use inverse, your record, okay, from your database, the domain record, the first coordinate will become the second coordinates. The second coordinates becomes the first coordinates. Okay, swap. You swap. But you are not actually swapping the database. You are actually telling that you are reading like the balik, but it's not swapping the original data. No, you are not swapping the original data. You are telling that in order for you to manipulate the record here, you have to read the record the other way around. Okay? From the right to the left, not the left to the right. Okay? So that is what you mean by that. But the original data still remain intact. No changes in the original data. Just like the way that when you want to manipulate the data, okay, you are reading from the second coordinate, then you look at the first coordinate. It's a swap. Okay, you are swapping, something like swapping. Okay? So that is actually what we call as inverse operator. Okay? But of course, when inverse, you have to look in terms of how to write the answer, you have to change. Okay? Because in order for us to see what you understand from that, you have to write the answer like the balik one. So the domain become range, range becomes domain data. Okay, so that's how you write the inverse data. Okay, the inverse data. So this is actually normally when you do this, okay, if you inverse, okay, you can do inverse like this. Just now we talked about relational image, right? Okay, relational image, you are looking at the domain data. But if let's say you are looking at the range data, you can do inverse, then your data searching are actually from the range data. Okay, if you do inverse. Because now the range becomes domain. So you can do like that if you want to do more relational image symbol. Okay? So that's what you mean by this. Okay, so the next symbol is override. You have seen override already in our chapter, previous chapter. Previous chapter for the operation schema, right? When you want to update the records, okay, you see override. So the override is actually this symbol. Is to actually overlap your data with the new data, the old data. You override it with the new record. Okay, so that is what we mean by override. So if you are talking about database, if you want to override, you have to do precondition first. But you are given something like this, right? To either produce the result. So if the data does not exist in your database, but you use override symbol, that data will be added into your database. Okay, but if the data, if the record exists in your database, the old record will be override with the new record. Okay, but if let's say the record does not exist in your database, the new record will be added into your database. That is override. Okay, but when it comes to our operation schema later, if you want to override, that's why you learn precondition. So you want to override mostly, the data must exist. That is our condition. Should be the data must exist. So that's why your precondition is needed for you to do, so that you can override the data which are already exist in your database, not the data which does not exist yet. Okay, so that is actually the main purpose of our operation schema. So the main purpose of your precondition later. Okay, but if your question being asked like I give you the data, then I put the override. But the data that I override, I want you override is not inside the list here. The last or the final record will be included this data into your final record. Will be added to your record. Okay, but in your operation schema later is different because you have precondition. When you have precondition, you are going to check first. When you check, normally you are not going to add the record which does not exist. Okay, that is our purpose when we do precondition. Okay, so that is override. Okay, composition is another thing that you can actually, you can actually show in your record. Okay, composition means that assuming that you have two table, okay, two record, two record here, but the range of this record and the domain of this record are actually referring to the same thing. So you can actually do composition to show that the domain of, let's say, A and B here, the range of A is the same as domain of B. So you can show that there is a relationship between domain of A with range of B. So that's what I mean by composition. Okay? For example here, this one has phone, person to Z, phone in room Z, room here. So Z here actually have something which are actually the same. Okay, then you can tell that person here stays in the room here. You can say like that. There's a relationship like this. If you want to show that kind of relationship, you can actually show using composition. Okay, sometimes you want to show the relationship of the table as well, you can show using composition lah. Okay, you can show using composition. So normally you will do like this, but in order for you to show the relationship, we are going to use what we call as fact semicolon here. Okay, fact semicolon to show the composition. Okay, so means that has phone just now, the range of has phone is the same thing, okay, or got some data which are the same in the domain of phone in room here, okay, then you can do composition. Okay, so the result will be the domain from has phone linked to the range in phone in room here lah. So this is from domain has phone, this is range of phone in room here. So you can show the relationship if you want. So this is what we call as composition. Okay, composition. Some of you might want to show this table. You want to show that the domain of this straight to here, range of this. You don't want to stay in the middle here. Then you can show using composition. Okay, so that is what I mean by composition. So the symbol will be fact semicolon here lah. It's semicolon, but we call as fact semicolon. Okay, composition operator. So this is another example lah. Just now, name to phone, phone to department, for example. Okay, so you have phone. Okay, so this is the range, this is the domain. So same thing here. Then you can show that there is a relationship between name and department. You can do composition here. Okay, you can do composition. Something like this. Okay, you can show something like this. So the phone here in which department? If you see the extension here all start with 1, maybe this is the department. The extension start with 2, maybe this department. Extension start with 3, maybe for this department, for example. Okay, so from there you know lah. Okay, this phone is for this department, this phone is for this department. So, okay, so that is actually what we call as composition. Okay, so now let's do a little bit of exercise here. If let's say A here, what will be the answer for A here? What is the final answer here? A here. Wednesday only, yeah? Put inside curly braces, WD only, yeah? Because this is what we call as relational image. Okay? Relational image, you look at the domain, the result is range only. Okay? How about B? What is the final answer for B? Let me see. What is the final answer for B? Should be the same, right? Because this one does not exist, huh? So the last answer will be this one. The whole thing here, okay? See? Okay, so you have 4 answers lah. Susie 25, Adam 23, Lim 24, and then you added Cindy 22. Okay, so this is the one that I told you lah. If something like this, the new data does not exist will be added into your record. Okay? This one? Inverse terbalik So you put Malaysia 060, Australia 061, India 091, Singapore 064. Okay, so terbalik Can get the answer Okay, E. So the last answer will be April 30th, April 30, June 30, September 30, November 30. Okay? So that it will be the answer. And the last answer here. So this is anti-restriction Remove Remove the record. So none. 064 remove 061 remove. So left with 091 India and 060 Malaysia. Okay, for those who cannot get that, I will show you the answer here And see So that's how you write the answer. Okay? Okay. Let's see Okay? Okay, so let me proceed. Okay, let me proceed with function a bit. Then I will tell you how to continue with assignment. Yeah? So, because the assignment also include function, so that's why I have to explain a bit about function before you can proceed with the assignment. Okay, you have learned about relation already, So meaning that remember, relation, many to many relationship. Okay, so that's relation, many to many. So all the symbols that you learned just now, okay, is actually can be used with relation. Okay, so but there are cases where when you do your assignment last week so what I actually put in the Google Classroom is do Cartesian product. Then if possible during lecture, okay, you have to have, for example, primary key. Okay, if you remember I told you about primary key. Okay, right? Because when we talk about primary key, we are telling people that primary key cannot be duplicated. Right, that is our main purpose. Primary key normally will not be duplicated. So because we don't want the data to be redundant, we don't want to have redundant data. Okay, So if you want to have in your database data which are not redundant, so you cannot use relation already. Okay, relation is many to many. Okay, but there are cases that you need to use relation like phone number just now. But for some other cases where, okay, you actually cannot duplicate the record, then this is where you can use what we call as function. Okay, function. So function is actually special case of relation. It's a part of relation. Okay, it means that function is something like subset of relation. Something like subset of relation. Okay, it's a part of relation. Okay, but the only difference is the domain of the function will map to one range only. Okay, just now like phone number, staff can have two phone number, cannot. So now for a function, staff one phone number only. Another staff one phone number, but this phone number can be for two same staff, no problem. But one staff have one phone number means that one staff cannot in the database you can have extension only, but maybe not the handphone number. One phone number for each staff only. This is what we call as many to one relationship. Okay, many to one means one staff, let's say staff A, phone number A, staff B, phone number A, staff C, phone number B, for example. Okay? So this is what we call as many-to-one relationship. Okay? Many-to-one relationship. So many means staff A, staff B, one phone number. Many-to-one relationship. Okay? So we call this as many-to-one relationship. So means that the domain map to one range only. Okay? One range. So one domain, one range. Another domain, one range. Another domain, one range only. But the ratio can be met by many. This domain can be met by many domain. Okay, so this is what we call as many-to-one relationship. Okay, so mostly, okay, what we mean here is no distinct pair in the domain first. Means this is to represent something like primary key already. Okay, to represent something like primary key. So your domain normally will be the primary key. Okay, the primary key. So many-to-one relationship. Later, you will see also what we call as one-to-one relationship. So now, from your assignment, you don't know, right? You put the Cartesian product, right? So you may ask me, which one do I need to have? Is it many-to-many or what? This is where you look at your relationship, okay, your Cartesian product that you have done last week. If it is one-to-many relationship, swap, make it many-to-one. You understand or not? If let's say you have student ID to phone ID, for example, student ID to phone ID is one-to-many, for example, one-to-many relationship. Swap phone ID to student ID. So become many-to-one relationship. So when you have many-to-one relationship, you are not duplicating the domain. So when you are not duplicating the domain, automatically this is a function. Okay? So that's how you look into it. Don't have one-to-many, because one-to-many normally you have to use power set. Different little bit. So what we are going to do is, if you have one-to-many relationship, okay, make sure that the many will be the domain. The range is the one. Okay? So swap. So your relationship that you have done in your using your Cartesian product in your sixth space, you check again what will be the one that you have now. Okay? Is it many-to-many? Many-to-many, no problem. But when it comes to one-to-many, many-to-one, this is the one that you have to check. If many-to-one, no problem. But when it comes to one-to-many, swap it, make it many-to-one. Okay? So that is what you have to do in your next task for your practical session. Okay? Check again your state space, and then you proceed with the function of relation. Okay? So this is what you mean by function. Okay? So because this is a set, so the drawing here is to show, like I put the set just now, the set symbol. So the data here, okay, inside the set will not be duplicated. Okay? But in pointing to, you can point to many, one domain to one range. But the range here can map to many domains. Okay, so this is many-to-one relationship. Because one domain mapped to one range only, this is a function. Okay, this is a function. Okay, so you can have like this, you can have like this. You cannot have x1 mapped to y1, x1 mapped to y2. If x1 mapped to y1 and x1 mapped to y2, automatically this is relation already. Okay? So you have to check on this. What will be your record later? Okay? If no duplication in the domain, you go for a function. Okay? You go for a function. So this is example of a diagram to show a function. Okay? So in terms of set here, how to look in terms of data? If you have 1, 2, 3, no duplication inside the domain. We are talking about domain data. We are talking about domain data. So no duplication inside the domain here. This is a function. But if let's say you are looking at the second one here where you have 1A, 2B, 1C here, 1, 1 here, this is not a function. This is a relation. Okay, the domain cannot be duplicated for us to say a function. Okay, range no problem. You can duplicate in terms of set style, set writing, range you can duplicate. Okay, but in terms of diagram just now, like I told you just now, that one cannot. You understand or not? We show you different way. So when you want to show a set of records, you can duplicate the data. But when you want to show as a set itself, then you cannot duplicate the data. Okay, understand? So meaning that you go back to this one, right? So this is what you mean. I mean this one. Okay, so if set, you cannot duplicate. But when you go for this one, you can duplicate because this is the record in your database. But for function, the domain here, you cannot have this one because this is not a function anymore. So means you cannot have that. That is a function. Okay, if you have this, this is a relation. But if you don't have this, this is a function. Okay, means you cannot duplicate the domain data here. Okay, you cannot duplicate the domain data in your database. Okay, so that's what you mean by function. Okay, so this is another example of a function. Okay, so because your domain is not the arrangement is not important. How you want to rearrange your record doesn't matter. So that's why I put 2, 5, 3, no problem, the arrangement. Okay, but this is not a function because you have 1 here, the domain 1 here, duplicate already the domain. So that is not a function anymore. Okay, that is not a function anymore. So, if let's say before this, you change you assuming all your relationship from Cartesian, you change to relation, for example, right? From Cartesian product, you change to relation, then you put double-sided arrow. But after you have done that, you want to improve your relationship, then you ask yourself, do you duplicate your domain data or not? If no duplication of your domain data, then rather than you use double-sided arrow here, then you update to become another what we call as function. So maybe you can use this symbol. Okay, so later you will see the symbol for function. Okay, so when you do your operation schema, but of course for your assignment, my suggestion is straight away you go for look at the primary key, then if no duplication, automatically it will be a function. No need to you consider relation or whatever, no need. If no duplication of your domain, automatically it is a function. That's all. Okay, automatically it is a function. Okay, so when you go for function, okay, we call this as what we call as function can be applied. We call this as function application. What it means by this, okay, because when you go for function, your result will be one range only. You won't have many range data. Okay, that's what we mean by function application. Means you give the domain, your result will be one range. Yeah, you will get one range data. So you get the concept is similar like relational image design. Okay, you provide the domain, you can get the range data. So but the range data that you get from a function will be one range data only. Okay, one range data. Relational image, you may get more than one. Okay, you get more than one. Follow your keyboard. Okay, but when it comes to a function, when you want to, let's say you want to search the domain, okay, we call this as function application. You want to search the domain, your result of range will be one record, one data. the result will be one range result. So we call this as function application. Okay, the term that we use, we call this as function application. Okay, so you can write, the way to write, later you will see, either fx or f bracket x. Okay, f is your function, is your variable later. X is the one that you want to search. Okay, x is the one that you want to search. Okay, so something that you want to search is either with bracket or without bracket. Okay, with bracket or without bracket, it's the same thing. Okay, so I think you have learned about fx like this, but this is mathematics symbol. But for us later, will be your variable name and also your data that you want to search. Okay, but the way to write is with or without bracket. Okay, with or without bracket. But if let's say the data that you want to search does not exist in your database, the result that you get will be undefined answer. Okay, the result that you get will be undefined. So that's why when you want to use function, you have to do precondition checking before you can search. Okay, if you want to search something, you have to do precondition first. Because if the data does not exist, the end result of function application will be undefined answer. So if you write code, your result will be like jumbled up answer that you are like, what is this kind of answer? Okay, so that's what we call as undefined answer. Okay, so that's why it is important in your operation schema later to do precondition. Okay, if you don't have precondition without checking, you will have undefined answers as your result. Okay, so for example, okay, about function application that you are going to have mostly, because you want to do checking, for example, normally you will have an input variable. Okay, so input variable is the one that you are going to check normally. Okay, you do the precondition for your input variable. Okay, and then the output normally will be the range data only. If the input variable follow the operation exists or does not exist according to what you want, so according to your precondition, the end result will be your range data only. Okay, the end result. Okay, if let's say exists, the result will be the range data. Okay, so that is actually what we call as function application, and there is only one result as your output. Okay, so that is actually function application. So if let's say you use a function application, the variable that you use mostly will be singular word but if you use plural also no problem. But most of the time you will see that it's a singular word. Okay, I just use the same example for just now. For that is not the correct example because you have duplicate record. But I just want to show how to write the way to write the function application. You use your variable in front with or without bracket. Okay, with or without bracket, then you get the result, the range result. Okay, but of course, if you refer to the table just now, that is not a function But I just want to show here in this example only how to write the statement there using variable and the data that you want to search. Okay, so you can use bracket or you can use without bracket. Okay, so this is function application. Okay, so this is another example. Okay, so you can put with or without bracket So day is your variable. So if I put 2, I will get Tuesday as the result. Or without bracket, I will get the same answer. So don't get confused when you see day 2 here, you will assume which day. So this one means function application. And then if you put day 4, the result will be undefined. Okay, so that's why if you want to do something in your operation schema later, you need to do precondition checking first, so that you won't have undefined answer on result. Okay? Okay, so same thing as your other variable declaration. So when you want to do function declaration, is similar like what you did previously, assuming that I have two basic type ID and name here, and then we are not going to have two IDs inside our system lah. Means each of you will have different ID, yeah? So we are not going to have duplicate ID in our system. So this is something like primary key already. So how to write this? Okay, so you can have what we call as this symbol. So this is a part of function symbol only. Okay, a part of function. So relation, double-sided. Okay, double-sided arrow. But other than that, normally will be a function. Okay, will be a function. So this symbol, you see one arrow, one-sided arrow, but you have a line in between here. We call as partial function. So this is the general symbol for our system. If let's say you have a function in your system, minimum symbol that you are going to use will be partial function symbol, this symbol. Okay? So when it is a function, I will assume I will see at least this symbol. Okay? If it is a function. Okay? Other symbol that you will learn later is okay. If you want to put it or you want to change whatever, is okay. But the minimum that you are going to have in your Z schema, okay, if it is a function, should be this symbol, partial function. We call it as partial function. Okay? So normally when you do a function, as I told you just now, because you will get only one range result. So the variable, okay, we try to go for singular word. But it's okay if you, let's say you go for plural word, it's not problem. Just that normally, if it is a function, the variable that you use normally will be singular word. Okay, singular word. So, but if relation, normally we will go for plural words. Okay, so but this one is not compulsory, it's not compulsory, but it's more like a good practice, a good practice of how to write Z statement, Z declaration and so on. Okay? So this is a partial function just now. So that is the symbol. We call this as partial function. Okay. So this is how you want to declare. Where to declare? Normally inside your state space schema. So this is how you write your declaration. If let's say you want to use cardinality, no problem. You can just simply use hashtag. Whatever that you learn cardinality, same for relation, same for function, no problem. Just use hashtag. Okay, so the record will be calculated accordingly. Okay, so that is cardinality. Okay. That I think this one I will continue later. Next week, can because I need to explain to you how to proceed with your assignment already. So now let's say let's say I have student as my module. Okay, assuming that I have student as my module, so I have done student ID. For example, for this I have common set of ID. Okay. Okay. I have student name. Example, power set. Okay. I have ID. Okay. Cartesian product name. Phone number. Let's say you have phone number. Power set. Yeah. So in the database, okay, because data I want to show, each student phone number, you can have maximum 2 phone number. For example, okay, maximum 2 phone number for each student means they can have handphone number and they can have house phone number. So maximum 2 you can enter assuming. Yeah. So, but before that, you have to show this is your state space. This is what you have started last week to do the Cartesian product. Okay. So remember, okay, if you have the same type here, you need to show the link between these figures. Okay. So it means that you have to show the link between student ID, student name, student phone, and student age. Okay. So in this case, for student name here, normally I will go for pair first, rather than the primary key. So I will go for the second, third, fourth, and so on first before I assign to or make it the same as the primary key. Okay, so I will go to the student name first. So the one that are the same for all here will be the ID. Okay, same for basic type here, the same are the ID. Okay, so I look at the student name. The ID here, okay, so you have 2. So the first one we call as domain. Okay, we call as domain. So same thing here, student phone also domain, student phone, student age also domain. So what you will do is you put dom, student name. I will put equal. You can put subset, no problem. Dom, student phone equals to dom, student age equals to student ID. Okay? Student ID. Okay? So that is actually what I was doing. Okay? But as I told you just now, maybe I want to say that maximum for each of the students phone here, maximum 2 phone number. Okay, 2 phone number. So actually you can put hashtag, put bracket, brand, student phone, for example lah. You can put like that. But this one haven't learned yet lah. No, I will show this saja. Okay. Let's go for this simple one first. Okay, let's go for this simple one. Later give you a different heading already. Okay. So now this is your last. Assuming this is last week work lah. Then this week you want to start changing already your state space. Now you want to change to become relation or function already. So what you have to do is, of course you update this one and no need to copy paste inside your document. Only show one state space only. So let's say here. So you ask yourself, student ID 1 only and no relationship. Don't worry about that. Okay, don't worry about that. Just say like that. But now you go for student name. Okay? So your student ID here is your primary key. Okay, you make it ID here as your primary key. So meaning that the ID here will not be duplicated already. Okay, primary key. So no duplicate. So means that automatically the ID is domain. If it is not duplicate, means okay, but one student ID, one name. Another student ID, one name. But the name here can have same name but 2 students, right? Let's say you have Alex here, can be 2 students named Alex. So means that this one can be duplicated. The range data can be duplicated. So this is not 1-to-1 lah. Means that this is many-to-one relationship already. Okay, this is many-to-one relationship. So when it is many-to-one relationship, automatically this is a same student. Okay, that's what it means by this. Okay, so this is a partial function. Okay, so you change to that. Okay, the next one here, student phone. Okay, so assuming that the students can have 2 phones just now. Okay, 2 phone number, 3 phone number, doesn't matter. We just say general, more than 1 phone. And then you may have siblings study here, where the phone number also can belong to another student also, right? Maybe your sister or brother study here, so the phone number, your house phone number, he or she can also add it into the system, right? So it means that both of you can have same phone number, and then each of you can have more than 1 phone number. So it is a many-to-many relationship only. So after, if it is a many-to-many relationship, then what symbol we have to use? Relation symbol, right? So how to do that? Remove this one. Okay, this one change to relation. This one under relation here. Then you see double-sided arrow. Change that. Remove this arrow. Remove the bracket. Okay, so that's how you do the relationship. Okay, and then another one, student age. Okay, one student, how many age you can have at one time? How many age you can have at one time? 1 only, right? You cannot say, oh, today I am 22, today also I can be 24. Cannot lah. Okay, your age will be 1 only, yeah. But okay, many students, your age 22 here can be actually by different student. Student A may be 22, student B may be 22 also. Student C may be 21, for example. Okay, student D may be 23. So you can have like that. So is it a function or relation? Function, because one student only 1 age. So it is a function. When it is a function, same thing. You just do remove this, change the Cartesian product to partial function, then sorry? Yes, one student only can have at one time. Okay, so that's how you change from your Cartesian product to the function of relation. Down here, no changes. It's the same thing. Okay, because function and relation, okay, still use domain of. Okay, domain of. Okay. Okay, any question about this? Any question? Okay. Oh, another one. Okay. For example, because some of you say that, oh, I want to use my friend will be foreign key, foreign key, all those things, Okay, let's say, you want to actually, your operation later, you are the one who's going to do operation inside your module. The operation involves your friend. Okay, means that in order for you to do something in your operation, you need to get your friend information to proceed. Means that you may need your friend to be the foreign key to you, right? For example, primary key of your friend become your foreign key, right? Okay, so how to show that? Assuming I put here, let's say, just example only, student, program, for example only, student program, maybe ID, okay, one student, assuming program, okay, for example this program is program ID, not inside here. This is from your friend. Maybe your friend do the program management, whatever. about your friend. Okay, you can do like this. Okay, you can do like this. Okay, so it means that this is your ID, this is your friend ID. So you can do like this. Okay, but this one you have to check again whether correct or not. This is example only, yeah. This is example. But if it is many to many, then you change to become the relationship. Okay. Another one. If let's say I am talking about book, I still got time. Okay, remember I did for book last time. Maybe for book I have book ID. Assuming I have book ID. I have title. Okay, I have book ID. Partial function, title, and so on. Okay, and then I want to have another information. Okay, for example, in my library, I have another. For example, I have library book. Okay, example two. So I have catalog. Say borrow book, book, borrow, reserve, for example, and so on. Okay, power set of book ID. Yeah. So let's say I have this. Okay, the below part I will ID up to lah. Later you can add that yourself. Assuming that I have to do two state space. This is my first state space. This is another state space. Okay. Assuming I have these two state space. Okay. So when you see this state space, maybe this one I put different lah. Book info. Example yeah. Okay. Example I have this. So now what I want to do now is actually I want to say that there is a relationship between my book ID here and book ID here. Okay? I want to show because this is my module. This is my module. I want to show relationship. Okay? But I create two state space. I want to show relationship. So what I can do is, another way is, I create one more state space. Maybe I just put this down library book. Okay. I can do, take this one, state space name, put here. Take this state space name, put here. Okay, then I can take one only, no need to use all. Catalog. Maybe equals to book ID. Catalog is from book information. Okay. Then book ID, BID here. So same, book ID here. So you can do that. So this is what we call as schema inclusion from chapter 4. You can do this also lah. Okay? But we will discuss next week also another extension of this. Okay? Any question? This is just for you to actually think about it if you want to take it. So any question?